animals, cats on the right, dogs on the left, we have Rasheed Wallace, Henry, Eli, Hank, and Jack. So we asked each of the dogs a question. Each of them had to answer the question, which cat would you most want to hang out with? And here are their answers. So here are their answers. You can see them drawn up by these little tiny pieces of string. Oh, here we go. Rasheed Wallace loves the string, and he's coming to interrupt my recording. Rasheed. Okay, anyway. Jack said he'd like to hang out with Henry because they're both pretty mellow. Hank finds Rasheed more fun because he's more playful, and Eli likes the mellow of Henry. Now note that each of the dogs made one choice. So Jack maps to Henry. We say that he maps to that because he picked Henry. So Hank's choice is Rasheed. So Hank maps to Rasheed, and Eli maps to Henry. Okay, so now I've got a new question. We're going to ask the cats who they could beat in the game of chess. So if the cats, like Rasheed right here, if the cats were playing the dogs in chess, thanks Rasheed, who could you beat? Okay, the cats made their choice. Oh, come on. Get out of the way. We're trying to make a map. Okay, Rasheed has agreed to cooperate now, and the cats have spoken. Rasheed says that he could beat Jack and Eli in a game of chess because he doesn't think that either of them too smart. Now, Jack intimidates Henry, so Henry could only beat Eli. Now, there was one big difference here between this relation and the other we looked at. This one is not a function. So the big difference, the thing that, excuse me, Rasheed. So Rasheed has two, Rasheed, come on. I'm trying to show something here. We're trying to make a math video. So the thing that has to happen in order for it to be a function is you can only have, okay, we'll wait. We'll sit here and wait. We've got lots of time. Rasheed Wallace maps to Jack and to Eli. That, it makes it not a function. One thing can only map to one other thing. Okay, so now we're going back to the question of which cat would you want to hang out with. We asked the dogs here which cat they'd like to hang out with. So this one is a function, and we've got those mappings back. Jack map, and we've got our helper back again too, as he loves strings. We're probably just going to have to sit and wait for him. Rasheed. Oh, there he is. I think, did he swallow the string? Okay, anyway. We see that on the left side, we've got Jack mapping to Henry, Hank maps to Rasheed Wallace, Eli maps to Henry. Jack maps to just one, Hank maps to just one. So these things on the left, these dogs, since these are the ones that we asked here, we give a special name for everything on that side. And everything on that side is called the domain. So everything that goes in, everything that was on the beginning of the function, everything that does the mapping is called the domain. So in this case, Jack, Hank, and Eli are all elements of the domain. On the other hand, everything that gets mapped to also has a name called the range. So everything that gets mapped, the cats in this case, are all parts of the range. So in this case, the range has two elements, Rasheed Wallace and Henry. So in your math classes, you probably haven't done a lot with dogs and cats. Instead, in math classes, we work with numbers. For example, we might start with the number 3. So 3 is in the domain, and 3 maps to 6. So we see in this case 3 mapping to 6. We can try another example. In this case, we've got 5 in the domain. Was 5 mapped to 10? So in this particular function, 5 maps to 10. Try another one. Negative numbers. We can have negative numbers in this function. Negative 2 maps to negative. One other thing to notice is that a number can be in both the domain and the range. So we can have 6 in the domain mapping 12, or we can have 6 in the range mapping from 3. Either way works. Just like the others. And one thing, on the domain we commonly refer to these as x values. In the range we call these y values. So domains are the x's, ranges are the y's. What's the rule based on these mappings? Can you figure it out? I'll show you the mappings one more time. 3 goes to 6, 5 to 10, negative 2 to negative 4, 6 to 12. So what's the rule? What gets from the domain to the range? From 3 to 6, from 5 to 10? So the rule here is y equals 2x. You take the number in the range by taking the domain number and multiplying it by 2. We're going to learn a more sophisticated way to do this, though. It's called function notation. Function notation, we read that it's f in parentheses x, f of x equals 2x. That's the general rule, but if I want to show something specific, I'll put the domain number in the parentheses, and it equals the range number. Try it with 5 and 10. F of 5 equals 10. We can try it with -2 and 4 too. F of -2 equals -4.